You paste in an API key, write a quick prompt, and watch the terminal light up. For a few glorious minutes, you have an autonomous AI agent doing exactly what you asked. Then you give it a real task. The context window quickly fills up with irrelevant data, and the external API cuts you off because you hit a rate limit. Next, it hallucinates a tool call, gets stuck in a retry loop, and quietly drains your billing account while you're away from the keyboard. And when an unhandled error finally halts the script halfway through a massive job, every piece of progress it made is instantly wiped out. Building a prototype that works once is a parlor trick. Keeping it alive in production is a systems engineering crisis. The Harness template library was built to solve exactly this. Interestingly, the entire codebase was generated autonomously by an AI engineering agent named Neo. The library operates on a strict division of labor. It separates the agent's behavior and personality from the 15 underlying infrastructure modules that actually keep the system running. One of those modules is the retry recovery system. When the API inevitably throws a rate limit error, this block intercepts the crash and quietly retries the connection with exponential backoff until it goes through. Meanwhile, the state manager runs continuously in the background. It checkpoints the agent's exact progress after every single step, ensuring that if a process dies, no work is lost. To keep the token budget under control, a dedicated memory layer actively searches past sessions for specific keywords, feeding the agent only the context it needs right now. These unseen modules take a fragile Python script and turn it into a durable, resilient software machine. But resilience alone isn't enough. An autonomous system needs strict boundaries. The budget manager tracks token usage and calculates the exact cost in real time, completely synchronized with every action the agent takes. The moment a session hits its preset dollar limit, the system triggers a hard stop error. When a session hits its dollar limit, the system triggers a hard stop error. It physically severs the connection to the API, immediately halting the run. For sensitive operations, there is a hardwired human approval layer. If the agent tries to execute a critical command, the process hits a wall and pauses until a human operator confirms the action. Whether you approve or deny the action, an audit logger records the exact tool call, the agent's reasoning, and your decision into a permanent append-only ledger. You can't trust an autonomous system by asking it to behave. You trust it by enforcing absolute physical constraints it cannot bypass. Because those 15 infrastructure modules handle all the failure states, developers can immediately snap them into 10 specialized, ready-to-deploy agent templates. The coding agent template provides a software engineer out of the box. It reads your file system, writes code, runs its own tests, and automatically fixes the bugs it finds. The finance operations agent handles entirely different logic. It processes invoices and checks balances, but its configuration permanently forces every single financial transaction through that manual human approval gate before a cent moves. Or you can run the multi-agent orchestrator, which takes complex tasks, splits them into parallel work streams, and delegates them to smaller subagents before merging the final results. The heavy lifting is identical under the hood. One robust foundation seamlessly supports completely different domains. This entire system hinges on one very specific architectural choice. Every memory layer, state checkpoint, and audit log is written entirely to local SQLite databases. There is no need to provision external vector stores, spin up cloud servers, or configure complex network routing just to make the agent remember a previous conversation. Because the footprint is so small and completely self-contained, these agents can deploy securely inside an air-gapped network or run quietly in a temporary CI pipeline. Developers no longer have to spend weeks writing custom backoff decorators, token math functions, or error handlers. They can focus purely on the core logic. Deploying a resilient, accountable AI worker used to be a multi-month engineering project. Now it is ready on day one.